All right, so in this lesson, we are going to look at special cases of polynomials that we can factor and try to build connections to what we already know about factoring quadratics and other polynomials. So whenever you're factoring a polynomial, the first thing you should always look for is a GCF. All right, and then so number one, okay, 3x minus 6. That is a linear polynomial, okay, and I get factor out a 3. Right? So put the 3 on the outside, you're left with x minus 2. So now it's in factored form. All right. Number 2, x squared minus 4. Again, this is a quadratic binomial. All right. So we want to, there's no middle term. Okay. This is the difference of two squares. So what you're trying to do is you're trying to think of two things that multiply up to -4 and add up to 0x, right? And so that's just going to be 2 and -2. Right? That's the pattern, the sum and difference pattern. Okay, so x minus 2, x plus 2. Again, I could put a plus 2 first. It doesn't matter. Okay, this is a difference of two squares. And we could even have the difference of two squares, like if this was x to the 4th, right? X to the 4th is a perfect squared. Okay, so I could have x squared and x squared there. All right, so x squared plus 2x minus 2. Now, this is a quadratic trinomial. Leading coefficient's 1. Okay, there's no GCF, so we are going to look for what multiplies up to -3 and adds up to 2. So we know we're going to have our two linear factors, okay, where x has to be the first term in each factor, because that multiplies up to x squared. Now we're looking for what multiplies up to -3, so it's just going to be 3 and 1, and the 1 will have to be negative because we want to add to 2. So x plus 3 times x minus 1 are the factored form of that standard form, x squared plus 2x minus 3. Okay, now here we have a quadratic binomial times a quadratic binomial, and we just want to find the product. We want to FOIL this out. Okay, and so x squared times 2x squared, that's 2x to the 4th. And then I get x squared times 1, that's x squared. Then I get 1 times 2x squared, that's 2x squared. And then 1 times 1 is 1. Okay, now I look, do I have any like terms? I do, right in the middle, so I combine my like terms. 2x to the 4th plus 3x squared plus 1. Okay, so what is this? This is not a quadratic trinomial. This is a 4th degree trinomial. All right, but the factored form look very similar, right? It follows that same pattern. If I wanted to try to factor this 4th degree trinomial, the answer kind of looks the same, except instead of x and x, I have x squared and x squared because it was x to the 4th. So this is even. I can split it up in half, right? And I'll know what is going to go first. But in order for them to combine and get like terms, right, this exponent would have to be half of that one. All right, so if this was 6, this would have to be a 3. And then I could factor it as long as I could do what multiplies up and adds to feature of it. All right. So I'm going to take some notes right here, get it done on your nearpod. All right, and make sure you're using the notes feature so it sends you the notes. All right, so x squared plus 6x plus 5. Well, we want to find the zeros. Okay, so same thing as we did last time. We're going to factor it. So x plus 5, x plus 1. And then we just have that one extra step of solving. What makes each factor equal to 0? And so that'll be -5 here and -1 here. Remember, graphically, right, we found the x-intercepts when we do this. We want to know when it equals 0, that's the x-axis, right? We call them zeros, roots, x-intercepts, okay? So that's what we're looking for right there. Okay, so now, right, we have this Quadratic Trinomial. Okay, if we just notice from our warm-up that if this is even, I could split it in half. As long as this number is half of that, I could factor this, or I could attempt to factor it at least using the same technique as before. So now I know it's going to be x squared in each factor. And then what multiplies up to 5 and adds up to 6? So the same thing as before. So plus 5 plus 1. All right, and now when I solve this, all right, I can't. Well, I can, but I can't. I'm going to get x squared plus 5 equals 0. And when I subtract 5, I get a negative over there. So I get x squared equals negative 5. So I don't really get a real solution. I'm going to get an imaginary solution. So when I square root both sides, I'm going to get x equals plus or minus, and there's a negative inside, so an I comes out, and then nothing I can do with the 5, so that stays there. So plus or minus I rad 5. Same thing's going to happen here with the x squared plus 1. If I subtract 1 over, I get x squared equals negative 1. And when I square root both sides, all right, I just get x equals plus or minus I. So the technique to factor was the same, but now when we're solving, okay, we need to look and solve a quadratic instead of just the linear. So it's a little bit extra work. And remember, sometimes you might get a quadratic here that's still factorable, right? What if I get like a difference of 2 squares showing up here? And I could keep factoring it out. All right, so lots of similarities, especially in the technique. We call this the quadratic pattern for factoring, and it works when there's a trinomial with an even degree, and the second term is half the first exponent. Right, so 4 is even, 2 is half of 4. Right, if this was 8, right, 8's even, this would have to be a 4. Right, 10, this would have to be a 5. So we could do the quadratic pattern for any trinomial that has that kind of setup, and then the numbers obviously still have to work, right? They have to multiply up to this and add to that. Okay, so with that in mind, which ones here, okay, could the quadratic pattern work on? So I'm looking for trinomials where the first term is an even degree, so it's an even degree trinomial, and that second term, that middle term exponent is half of the degree. So this first one will work. All right, and again, what multiplies up to 10 and adds to 11, that's 10 and 1, that'll work. Okay, 4 is even, but 3 is not half of 4, so B will not work. All right, 4 and 2, so that works. Can I think of anything that multiplies to negative 6 and adds to 1? All right, 3 and negative 2, so C works. And this is not a trinomial, so the quadratic pattern will not work on this. There's a different strategy that we'll learn when we get 4 terms. All right, so let's practice. If you guys just take notes with me here as we do a few. All right, so we're going to solve by factoring. All right, so what's going to multiply up to 15 and adds up to 8? Okay, and so that'll be x squared to start. And then that's 5 and 3. All right, so x squared plus 5, x squared plus 3. All right, and so when I solve both of these now, right, I'm going to subtract 5, right, so I get x squared equals negative 5. But I don't want x squared, I want x, so I have to square root both sides. And so just like on the previous exercise, the I is going to come out, so plus or minus I rad 5. And again, I can't simplify the 5, but if I could, I would. All right, so if it was like an 8 there, I would simplify it to 2 rad 2, but it's not. Okay, so here I get x squared equals negative 3. Square root both sides. So x equals plus or minus I rad 3. All right, one more example here. Number 2, we got x to the 4th minus 4x squared minus 32. So on this one, yes, okay, quadratic pattern works. It's even, that's half. What multiplies up to negative 32 and adds up to negative 4? That'll be what, negative 8 and 4. So right here, I'm going to get, oops, Okay, x squared minus 8 and x squared plus 4 equals 0. All right, these are you can't factor them anymore. If this was x squared minus 4, I could keep going with x plus 2, x minus 2, but it's not. It's plus 4, so I can't factor that. All right, it's not the difference of two squares. All right, so right here, I'm just going to go ahead and solve. So x squared equals 8. And so when I square root both sides, I get x equals plus or minus, and then you want to simplify your 8. So 8 is going to be 2 rad 2. And then over here, I get x squared plus 4, so I'm going to get that. X squared equals negative 4. So this one will be imaginary. All right, when I square root that, x equals plus or minus 2i. Okay, remember, right, how come over here the 3 stayed in and here the 4 didn't? Because, well, 3 is not a perfect square, so 3 I could not simplify. But 4, right, square root of 4 is just 2. So make sure you're aware of why sometimes the radical stays and sometimes it doesn't with the i's. All right, so those are two examples for you guys to have in your notes. Again, make sure you're using the nearpod feature. It will just send you that stuff right to your Google Drive. Everything that you do will be sent to you. All right, so pause the video and you guys try this, and then when you're done, restart the video and check out your work. Okay, so I'm going to get x squared, x squared. So what multiplies up to 45 and adds up to negative 14? So it's both going to have to be 0, so minus 5 minus 9. Okay, so at this point right here, okay, I could keep factoring the x squared minus 9. I don't have to because I'm solving, but I can. It could be x plus 3, x minus 3. All right, so if the directions were to factor completely, you would want to do all the way to this line. All right, but these directions were just solved, so I could have solved at that point above as well. So right here, I'm going to get x squared equals 5. So x equals plus or minus rad 5. Here, x equals negative 3. And x equals positive 3. Notice how many answers am I getting, right? I'm getting 4 answers because it's fourth degree. Same with on the previous slide, right? I was always getting 4 answers for a fourth degree polynomial. Okay, some are real, some are imaginary, okay, but there's 4. And this one, it's 4 real solutions, two rational, 2 irrational, but they're all real. All right, here on number 4, we have what multiplies up to negative 8 and adds up to 7. So I'm going to get x squared plus 8 and x squared minus 1 equals 0. So again, if it said factor completely, I would want to write x squared minus 1 as x plus 1, x minus 1, kind of like I did over here. But the directions are to solve, so I'm just going to solve this. Okay, so x squared equals negative 8. So this will be imaginary. So x equals plus or minus 2i rad 2. All right, again, because the square root of 8 is 2 rad 2. Okay, and then the negative inside is why there's an I. So I have 2 imaginary answers. Over here, I'm going to get x squared equals 1. When I square root that, I get plus or minus 1. X equals plus or minus 1. So, and I have 2 real answers, 2 imaginary answers, but I still have 4 solutions, okay, to this problem. If I graphed it, how many x-intercepts would I have? I'd only have 2 x-intercepts because only the real numbers, okay, show up as the x-intercepts. But you do have, okay, 4 solutions, 4 roots to the problem. 2 complex, 2 real. All right, so here's some notes for you. All right, there is special cases, okay? Sum of two cubes, difference of two cubes. So when you have a binomial, a cubic binomial, okay, if the second number is also a perfect cube, right, then we could use this pattern. And again, it doesn't just have to be a 3, right? If this was a 6, anything that 3 goes into, 6, 9, right? And you could write it as a cubic, all right? And so you're looking for an exponent that is a multiple of 3 and then a perfect cube over here. We could factor it using this pattern. If you watch the Edpuzzle videos, there was a little saying there. How do you remember the signs? It's always the same numbers, right? So if it's plus, this is matches, it's the same, then it's the opposite and always positive. Okay, same, opposite, always positive, right? Same, opposite, always positive. All right, so they use the acronym SOAP to help you guys remember that with the pattern. All right, so you do have to know some of your perfect cubes here. We don't use really big numbers. So like if you know 1 cubed is 1, 2 cubed is 8, 3 cubed is 27, 4 cubed is 64. They get big pretty fast, right? 5 cubed is 125, 6 cubed is 216, right? And so they get pretty big. So you don't really need to know much more than the first few, right? But if you see these numbers start to pop up, I would start thinking, okay, sum or difference of cubes, especially if you're looking at a binomial. All right, so here we go. We have a couple to try here. We got one that's a sum and we have one that's a difference, okay? Notice, right, 8 is a perfect cube. It's 2 cubed. All right, so my A is X and my B is 2. And I'm just plugging that back into this formula. Wherever there's an A, I'm going to plug in X. Wherever there's a B, I'm going to plug in 2. All right, and so for this one right here, it's the sum. Okay, so my pattern is A plus B, all right, same, opposite, always positive. All right, same, opposite, same, opposite, always positive. Okay, so I just have to plug in the numbers there. Okay, so it's going to be X plus 2, then X squared minus, all right, 2X, always positive, then 2 squared is 4. So it's factored, all right? Find the 0, so I need to set this equal to 0 and solve. So this first one's easy to solve. X equals -2. Unfortunately, this second one is not easy to solve. Okay, this is not factorable. It's not a factorable quadratic trinomial. So I've got to use the quadratic formula. All right, so I'm going to go ahead and use my quadratic formula here. So x equals -b plus or minus the square root of b squared minus 4ac all over 2a. So x equals 2 plus or minus, and this will be the square root of -12. Okay, so I'll go ahead and show that. But boom, and then we have to simplify that. That's imaginary. Okay, so x equals 2 plus or minus, that's going to be 2i rad 3 over 2, and then all the 2's can simplify. So it's 1 plus or minus I rad 3 over 1, which I don't need to write the over 1 part. So my my 3 answers, right? I have one real, x equals -2, and I have 2 complex, right? These are called complex conjugates. 1 plus I rad 3 and 1 minus I rad 3. So in total, 3 solutions because my degree is 3. All right, again, I'm just using the pattern, okay, from the previous slide. This work's going to go away. All right, from the previous slide, I just plugged everything in. All right, and now I'll do the difference. Okay, now I'll do x cubed minus 23. Okay, so 27 is 3 cubed. So my a is x and my b is 3. I'm just going to plug all that stuff in and then solve. Okay, so x, the minus, the first one's always the same, so x minus 3. Then it's x squared opposite, so then a times b, so 3x. And then b squared, always positive. All right, so there it is factored. So now I could solve. So the easy answer, x equals 3. Okay, quadratic formula. So negative 3 plus or minus, square root is going to be negative 27. Okay, it's going to be 9 minus 36, so negative 27 over 2. So x equals negative 3 plus or minus 3i rad 3, because 27 is 9 times 3, right, all over 2. So again, I get one real answer, 2 imaginary. All right, and so again, total of 3 solutions, 3 zeros. All right, your turn, find the zeros. So pause the video and then check your work. All right, so I want to set this equal to 0. So I'm going to get x plus 5, because 125 is 5 cubed. Then x squared minus 5x plus 25. Okay, I'll get my easy answer. My easy answer is negative 5. Now I'll do my quadratic formula to get my 2 complex answers. That's going to be 5 plus or minus, and this will be the square root of 25 minus 100, so negative 75. All over 2. So x equals 5 plus or minus 5i rad 3 all over 2. So again, 3 answers, 1 real, okay, 2 complex. All right, so if I asked you guys to solve this equation, right, well, it doesn't look like the difference of 2 cubes, all right, but it is, okay? Why is it the difference of 2 cubes? Because always the first step is to look for a GCF. So right here, x squared will go into both of these. Okay, so I'm going to factor out an x squared, and that leaves me, or actually factor out a 2x squared. Okay, and that's going to leave me with x cubed minus 8. And now you have the difference of cubes, so you can get x minus 2, x squared plus 2x plus 4 equals 0. So now when I solve, right here, this will just be x equals 0 with a multiplicity of 2. Doesn't ask for multiplicity, so I'm just going to write x equals 0. All right, but there is a multiplicity of 2 because you got to think about it. I want 5 answers here. So this is really going to count as 2 answers. And I get x equals 2. And then I'm going to use the quadratic formula here, which we've already done. All right, so you're going to get 4 minus 16, negative 12. So 2i rad 3 all over 2. And divide everything by 2. So -1 plus or minus I rad 3. So again, I have 2 imaginary and I have 3 real. Remember, this is a multiplicity of 2. I only write it once, but it was x squared. All right. So I have 5 answers. All right. Answer the following questions. When factor and find zeros or solve an equation, what do you need the equation to be equal to before factoring? What says it right in the question? You need it to be equal to 0. Okay. Needs to equal 0 before starting. Okay. What should you always look for first when factoring? Always look for a GCF. How many terms are there in a quadratic pattern polynomial, right? 3 terms. We need it to be a trinomial. How many terms are in the sum and difference, right? We need that to be a binomial. You're just adding or subtracting 2 things, 2 terms. And so when you see something with 2 terms, you should be thinking sum or difference of cubes. When you see a trinomial, you should be thinking the quadratic pattern.